So I know unconformities can be a little bit confusing. So let's see if I can kind of help you clarify what you just read about unconformities. So the first thing I want to do is I want you to remember that an unconformity represents a period of non-deposition and erosion. So if you remember back when we did our cross-sections, that we talked about unconformities because we have to recognize them in relative time, right, when we are telling our story. Now, unconformities, if we were to look at them, let's say here we have a rock layer, right, and it looks something like this. It's always easy to spot them because they're going to be squiggly lines. Because when things erode, they don't erode evenly. So it's going to be really easy to visually identify them. Now we only have three types. There's only three types of unconformities. So what I want to do with you here is that I want to walk you through these three types because we name them just based off of the geometry. It's really pretty simple. So I'm going to come up with a checklist here for you and how to identify them. So you might want to write this down because it's probably going to help you when you go back to clarify your cross-section exercise on what kind of unconformities you have. So, let's say you are looking at your cross-section and you notice that you have an unconformity. Also, we want to give it a name. So the first question, question number 1, we have to ask ourselves, are the rocks below the unconformity flat or folded? So, are the rocks below the unconformity, and I'm going to do unconformity as you see, flat or folded? Now, first we need to figure out, why do I look below? Okay. Remember, when we talk about relative time, if I'm looking at a whole sequence and I see an unconformity, anything above that unconformity didn't happen at the same time. Remember, that happened later. So anything below the unconformity happened before the unconformity event. So remember, if we're talking about geometry of when the unconformity formed, we have to look at everything below it. So, when I say flat, what does that mean? So let's say here I have a sequence, and there's my unconformity, and the rocks below it are flat lying. Right? They haven't been tilted. If I see something like this, we call it a disconformity. Now, folded is going to be anything other than flat. So let's say there's my unconformity, and below this I see that I've got my rocks. Maybe they look like this, they're tilted. The rocks below it sit at an angle to the unconformity, so we call this angular. Pretty simple, hopefully. You're always going to use one of these two words. Either your rocks are flat or they are folded. So it's kind of like a first name. Your unconformity is always going to have one of these names. Now, the next question we have to ask ourselves to figure out if we have the third one. Do we have an igneous intrusion? So if you remember from the cross-section, the igneous intrusions kind of looks like these big black blobs, right, that kind of came through. So if my answer is yes, we're going to move on to question 3. If the answer is no, then we're done. That means you only use one of those two words that we did before. Either you're going to use angular or disconformity. Now let's go on to question 3. Say we say yes. The next question we have to ask ourselves is my igneous intrusion getting eroded, or did it get eroded at the unconformity? I'm going to show you what that looks like. So we're going to have a yes and we're going to have a no. So let's see what yes looks like. Okay. So let me show you how this develops. So let's say here we are. Let's say we've got these nice, lovely rocks here that are deposited. And then let's say I have an igneous intrusion come in here. Right? It's all solid black there, right? It comes in here. And then let's say now we've got, right, my erosion event. So my erosion event is going to wipe away, right? It's going to erase some of those layers. So what that's going to look like, there's my unconformity. So do you see how the intrusion is getting truncated? It stops. It got eroded. When I used my eraser tool, I erased through the intrusion. So that's an example of yes, my igneous intrusion is going to get truncated there. If it is, all we do is we add the word, because remember we are always going to use disconformity or angular. We're going to add the word nonconformity. Okay, so I'm going to show you what this looks like put together here in a second. Now what about a no? There's two examples of a no. Let me clear this here so we know that that's my yes side and my no side. So sometimes I might have an igneous intrusion, but it didn't get eroded at the unconformity. Okay, when it doesn't get eroded at the unconformity, we do not add that word nonconformity. So here's two examples of what that might look like. So let's say here I have my unconformity. Let's say my intrusion does this. See, my intrusion passes through the unconformity. Well, if you remember back to relative time, this tells us that my intrusion happened after the unconformity. It happened after even the deposition of that top layer. So I know there's no way my intrusion could have got eroded because it happened later. Another example of a no would be, let's say I have something like this. There's my rock layers, and here's my intrusion. My intrusion doesn't go up to the unconformity. So I actually have no idea what happened first. I have no idea whether my intrusion happened first or my unconformity. So either event, if I see either of these two things, I do not add the word nonconformity. So let's put this together. Let's go through a couple examples here. Let's say I see something like this. So let's figure out what kind of unconformity this is. So let's ask ourselves those questions. First question, are my rocks below the unconformity flat or folded? Hopefully you are all yelling out, they're flat. Right, so since they're flat, we're going to use the word disconformity. Now, next question, do I have an igneous intrusion? Yes. Did my igneous intrusion get eroded at the unconformity? If you notice, it is truncated, it is stopped there. So that is also a yes. So all I do now is I add the word nonconformity. So the technical name for this squiggly line is disconformity, nonconformity. Let's take a look at another one. Let's say I've now got one that looks something like this. This is a tricky one. Let's see what we got here. So, first question. Are my rocks below the unconformity flat or folded? Hopefully you all said folded. So if you remember, if they're folded, we use the word angular. Next question. Do I have an igneous intrusion? Yes. Is my igneous intrusion getting eroded at the unconformity? Well, if you notice, it's actually passing through it. So the answer there is no. So all this is just an angular unconformity. That's it. Let's do one more. Right. Let's say we've got rocks up like this. There we go. So, question number 1. Are my rocks below the unconformity flat or folded? Folded. So we use the word angular. Okay, do I have an igneous intrusion? Yes. Is my igneous intrusion getting eroded at the unconformity? Yes. So we add the word nonconformity. It's like having a first name and a last name. It's an angular nonconformity. So a couple of things here, a couple of rules, right? Besides those three questions. Okay, you're always going to use either the word disconformity or angular. Always. Now you can't use both. You cannot have an angular disconformity because your rocks can't be folded flat, or one or the other. Remember, you only add the word nonconformity, like the last name, if my intrusion has gotten eroded. Okay? Now you might be saying to yourself, gosh, why would a geologist come up with these crazy words to describe something when you could just draw a picture? And it's a great question. The reason why we do this is when we start to write our scientific journals, when we start to write our articles, and we're going through and we're describing to other geologists what we see. Okay? Sure, we could just include a figure and a picture and draw it all in there. However, figures in journals are very expensive. Sometimes the journals that I like to use and write in, they are $500 per figure. So why would I put in a figure of an unconformity if all I have to do is say I have an angular unconformity or I have an angular nonconformity, and automatically another geologist knows exactly what I'm talking about. So it saves us money and it paints a picture in somebody's head. Just like if you said, I saw a girl today that was 6 foot tall and had brown hair and brown eyes. Well, you might get an image in your head of what I'm talking about. This is the same thing. If I say I have a disconformity nonconformity, you know that I have flat rocks with an igneous intrusion that's getting eroded. So hopefully that kind of helped untangle that complex subject of what unconformities are. So now you can go back to that cross-section exercise and clarify all of those fun unconformities.